Okay, class, we're going to talk a little bit more about matrices and matrix operations. Here you see we have two matrices defined, matrix A and matrix B here. And we are going to add these two matrices together. And so we're going to see how matrix addition works. So this S standing for the sum of the two matrices is A plus B. And so when we add these two matrices together, we're simply going to be adding the corresponding elements, like so. So this guy plus that guy. So let's go ahead and see how this works. We have A11 plus B11, A12 plus B12, right? And it just goes on down the line like this in a similar fashion, like so. Okay, close off the matrix, and so of course these two went to here, these two are here, and then right here, and so on and so forth. Okay, so note that each element in the matrix will have a little S, a little star here that stands for element. IJ, right? So the ith row and the jth column equals Aij plus Bij, right? So it's the element Ij in the S matrix equals Aij plus Bij. So for instance, all this is saying is that we'll just do a random 1, 2, 3 equals A23 plus B23, right? Just that element. So that is how we, a shorthand we can use to describe what is going on in the matrix. Again, Ij is the ith column, ith row, and the jth column. So we'll say the ith row and the jth column. Alright, so that's kind of, a little general. Note that in order to add matrices together, they must have the same dimensions. Note that this A matrix is a 3 by 3, and so is the B matrix a 3 by 3. So you can, they don't have to be 3 by 3. All that's necessary is that each matrix that you're adding must have the same dimensions, or else you just can't add them. Okay, so let's go ahead and start by adding these two together. And when you add these together, remember it's just the sum of each element. So 1 plus 1, well, that's 2. Then you move on to the next one, 2 and 1 to get 3. 3 and 0 for 3, close it up. Move on to the next one, 0 and 0, of course that's 0. 2 and 2, that's 4. 3 and 1, also 4. And then we have 1 and 5, that's 6. 2 and 1, that's 3. And then finally 1 and 1, that's 2. Okay. In a nutshell, that is how you add the matrices together. Again, this is another 3 by 3. Why don't we go ahead and take a look at this in Excel. Alright, so first we type in the first matrix. Select where we're going to put it. Right there is fine. 1, 2, 3. 0, 2, 1. And make sure that you are entering this in along with me in your own copy of Excel. 2, 1. Okay, that's our first matrix, and we go ahead and identify it as such. And again, we are going to we're going to show that there's a plus. Type a space bar and then type the plus sign, or else Excel will think you're trying to do an operation. Alright, so 1, tab 1, 0. Then we go to the next one, 0, 2, 3. And then 1, 1, 1. Okay. And then this is going to equal. Again, type a space bar and then type the equal sign. So this equals this guy plus this guy. And then we just drag that across 3 and then down 3. And that is our sum matrix that we had from before. Okay. And let's go ahead and center that one so it looks nice. And right there. There we are. So we have the sum of those two matrices. Let's get back to the handout. Now we're going to add these other two matrices. We'll do it by hand first and then run through the Excel example. Alright, so again we're just simply adding each element in there. 0 and 1, that's 1. Next one, 2 and 1, 3. 0 and 0, 0. Oh, need to make that a little bit longer. There we are. We have 1 and 2. That's 3. 1 and 1 for 2. And then we have 1 and 1 again for 2 once more. And that's it. That's the sum of our matrix, right? The dimensions match, so we're able to do it. Example of one where dimensions don't match would be like 1 and 2 plus 3 and 4, right? You could not do that one because the dimensions do not match. Okay, so moving on to the Excel sheet. Okay, so we've got this first matrix entered in now. And let's go ahead, grade that out. Space and then the plus sign. And let's go ahead and center it so it looks nice. Then we do the next one. 1, 0, 1. And then the second column is 1, 2, 1. Alright, grade it out. Just so we can identify it as a matrix more easily. Come over here. Space equals. And center it. And just same as last. This guy plus this guy. And then drag it so that we have all the elements there. And just like we had before, 1, 0, 2, 3, 3, 2. Alright, now back to the handout. Alright, I already talked about this. Note that the matrices must have the same dimension to be added together. Then it says now to try adding some matrices in Excel. We just did that. Alright, matrix multiplication. Before going into multiplying one matrix by the other, let me talk real quick about scalar multiplication. And that's just simply where you've got some number out here multiplied by the matrix. So we'll just say 1, 2, 3. Well, this is the same as A times 2A, 3A, right? You just multiply by every element in there. And so if it were a square matrix or another rectangle, it'd be the same thing, right? Whatever is out here gets multiplied into each element inside the matrix. I guess we could go ahead and do that in Excel real fast. Okay, just set up matrix here real fast. This will be kind of random. Just type in random numbers here. And that'll be good enough to get the idea across. So here is our matrix. Let's go and gray it out. And so we have, 2 times our matrix. What will this equal? Oh, space equal sign. So this will simply be equals this guy multiplied by our element here. Now we're going to go ahead and put a $sign in front of the C and a $sign in front of the 20. If you do not put a $sign in front, as you drag and drop, sorry, not drop, as you drag across, that C20, the red box, will move along with your drag. You don't want that. You want that to stay the same. Okay, and so for instance, right here, instead of being this guy times this guy, you would have gotten this guy times this guy if you had not put the $sign in front. So you definitely want those $signs to be right there. And as you can see here, each element inside the matrix is getting multiplied by 2. Okay. Alright, and that's it. That's scalar multiplication in a nutshell. Oh, forgot to grade that one out. Alright, so back to the handout. Now we're going to talk about multiplying two matrices together. You do have to take the dimensions into consideration. You do have to worry about the order of the multiplication, right? When you're just multiplying numbers, 2 times 3, well, that's the same as 3 times 2, right? Doesn't matter the order. It's called commutative. You do not have that property for matrices. The order that you multiply does matter. And furthermore, you got to look at the dimensions. I'm not sure why there is an x here. That shouldn't. Oh, that's supposed to be times, I think. Okay, that's what that x is. That means times. So it's not mxk. It's supposed to be m times k. Just the font makes it look like the variable. So again, this is m by k matrix. Okay, that x is not a variable. That is simply m by k. Alright, so note that this guy and this guy are the same. They have to be the same. If they are not the same, you cannot multiply the matrix. Okay, and then note that the product of these two will simply be the outer dimensions here in blue. Just like that. So we want to look at first for the following matrices we have here. If these represent the rows and columns, first, can you multiply them? And then if you can, what will be the dimension? So here, if you multiply this matrix, right, we note that these two dimensions are the same, right? The columns in matrix A are the same as the rows in matrix B. And so the resulting matrix will be 1 by 1, right? It'll be one element in that matrix. Okay. Note that if we ran it in the other direction, you would get B of a 2 by 1 times A of a 1 by 2. And so in this case, they match. So you actually can multiply in the reverse, but note the dimensions are going to be different, right? The product of this matrix will be a 2 by 2. Order matters. Not only will you get different elements, you'll get a matrix of completely different dimensions. Alright, let's look at this next one. Right, 8 and 8, so you can multiply these two matrices together in this fashion, in this order, and the result's going to be a 5 by 1. And if we do this in the reverse order, 8 by 1, and then A is a 5 by 8. You look at these two numbers here. You note that they do not match, so you cannot multiply these together. and so this is simply a does not exist situation. Order matters. Alright, so here we got a 3 by 2 multiplied by another 3 by 2. You note that you cannot multiply these two together. This is a does not exist situation again. And if you did them in the other order, you would still have a does not exist situation. Alright, last one. A 3 and a 2, they do not match, so you cannot multiply these two together. So this is again a does not exist situation. Note that if you did these in the reverse order, B of a 2 by 1 times A of a 1 by 3, you can multiply these two together. Right, because the 1's match here, and the result will be a 2 by 3 matrix. So this would be, the product would end up being 2 by 3. Alright, so in summary, the order of multiplication of matrices does matter, and the columns, the number of columns in the first matrix must match the rows of the second matrix, and then the product will simply be these two outer dimensions right there. Okay, so we're going to just work a couple of examples. We want to look at the example of a 1 by 2 and a 2 by 1. So in a 1 by 2, our matrix would look like this. A1, 1, and then A1, 2, and then close it up. Probably don't need that. There we go. That looks better. And then the B for the 2 by 1 is a B1, 1, B2, 1, and that's it. Alright, and so the multiplication goes this way, and then you go this way with it, right? So you're going to simply be adding, multiplying and adding different elements together, and so this will look like this. A11 times B11 plus A12 times B21. Alright, again, you multiply this guy with this guy, and then you multiply this guy with this guy. And, you know, for longer, you just continue that pattern. So let's do an example with this. Let's just do kind of a simple one, 1, 2, and we'll make the matrix here 3, 4. So again, we're running this way and this way. Note that what we're saying about the dimensions, right? We got two columns here, and we got 2 rows here. They match. That's what we need. And the outer dimension here, like this is a, I'll actually show it right here. So the 2's match, and then you see the outer 1 and 1. So this ends up being a single element matrix, just like that. Alright, so let's multiply this through. Alright, the 1 multiplies with the 3. And then the 2 multiplies with the 4. Giving you a 3 plus 8, which is simply our matrix 11. Okay, let's look at this in Excel real fast. So we set up our first matrix right here. 1, 2, 1, 2, 3. Go ahead and gray this in. And we're multiplying this. Hold on, let me go ahead and center this. Times our second matrix, which was 4. Oh, actually we did slightly different dimensions, but this will be good because this will show us how to do matrix with a slightly different. Note that this is a 1 by 3, and then we're going to a 3 by 1. So the result will also be a 1 by 1 matrix. And so we got to set this up. So this guy times this guy plus this guy times this guy, and make sure you're doing this with me, plus this guy times this guy here. So the result of that is 32. Alright, and if we can kind of do whatever we want. Let's go ahead and do another one. Let's do, as long as the dimensions match. So this has 7 elements. So our row is 7, so that means we got to have 7 columns in the next guy. So let's set up as so, and let's make this one, 8, 9, 10, and 14. There we go. And let's go ahead and get that there. So now we're going to go ahead and multiply these matrices together. So again, equals 1 times this guy. And make sure when you're working this together, I know that there is a operation, or a command you can put in Excel that will automatically do this for you, but I want you to go ahead and run through the practice of typing these in individually. It will pay off when you are trying to understand what is happening with the matrices. So at least do this at first. I understand if down the road you start getting more proficient, you can start using Excel commands at your disposal, but for right now, let's do it this way. Alright, plus this guy times this guy. Alright, just keep going down the row. Alright, and so the result of all that is 336. And so once again, you see how it goes. That's pretty much it. Alright, so let's take a look at some more interesting ones. A22 by B21. So we note already that the dimensions do match how we want them, and so this is going to end up being a 2 by 1 matrix. And so let's go ahead and look at this one on this basis: A11, A12, A21, A22, and this is being multiplied by our B matrix, which is B1, 1, and then B1, 2. Close that up. When you multiply through, again, you're going to have this guy is going to go to this guy, and then this guy is going to go to this guy. Sorry, I should have written it like this. There we go. Going to go to this guy here. So that first element equals A11, B11, plus A12, B21. Alright, and so note this is going to have two columns. And so let's see. Yeah, we'll use this. Yeah, we'll still use the same color then. A21 still goes to B11, and then A22 will still go with B21. And so it ends up being this. A21, B11 plus A22, B21. Alright, and that's it. That's the general idea. Let's go ahead and take a look at this with an actual numerical example. So we have 1, 0, 2, 3, and then let's do a second one here, and we'll make it 2, 2. So when we multiply across, again, this is going to be 1 going into the 2. So the answer there is 2, and then plus 0 going into the 2, and of course that will be 0. Then we go to the next element. 2 times 2, which is 4. And then 3 times 2, which is 6. So this ends up being the matrix 2, 8. Alright, that's pretty much it. That's how you do this matrix by hand. Let's take a look at an example in Excel again. Alright, so we'll set up our matrix. 1, 2, 3, 1. And then we'll have our second matrix here. We'll make it 4 and 5. Okay, so again, let's go ahead and gray it out so we can see what's what. Here and here, and again we are multiplying these matrices together. And then space equals. Alright, so we multiply this through, again 1, or that guy, times this element here, plus this element here times that element there, and that's it for that element. And then you go here, equals right here, back up to there, plus this guy here times that guy there. And that's it. That is your matrix. Gray it out. Alright, now back to here. A22, B22. Again, inside dimensions there are the same, so the result will be the outer dimensions there. This, two square matrices, so the product of them will be the same square as those two guys. So let's go ahead and look at this. A11, A12, A21, A22, multiplied by B11, B12, B21, and B22. Right, so note it's the row, then the column is how the order goes. It's going to follow a very similar procedure. Right, A11 gets multiplied by this guy. A12 is going to go to this guy right there. And that will be our first element. There and there. Okay, so B21 to A12 and A11 to B11. Element number 1. Now for element, the element that goes here, the 1, 2 element, A11 gets multiplied here, and A12 gets multiplied here. Same pattern as before. So A11, B12, plus A12 times B22. Alright, so again, A11 still, B12, and then A12 again, and B22. Alright, so going on to the next, the bottom 2 elements, same pattern. It's going to be A21 gets multiplied over here by the B11, and then A22 gets multiplied here by the B21. And so you write it out like such. A21, B11 plus A22, B21. And then the last element, A21, now we're going to over here, over here. So it's going to be B12 plus A22 times B22. Okay. So again, note that it's going across this way, and then you multiply going down that way. That's how it's always going to look. And so note that right here, the Sij element, right, so Sij should say Pij element here is simply can be expressed in the following format, where I is the number of, or is the where you are in terms of rows, and J is where you are in terms of columns. So if you kind of just double check for each element here, right, this would be the element 1, 1, I is 1, J is 1. This is element 1, 2, I is 1, J is 2. Right here, this would be the element where the we're in the second row, first column, so that would be 2, 1. And here we're in the second row, second column, I is 2, J is 2. So go ahead and double check this one on your own to make sure it matches each one of these 4. It does, but I want you to verify that on your own. It is good practice. You'll understand things better if you do that. Alright, so let's look at a quick example here. We'll try and keep the numbers kind of simple so it doesn't get out of hand during the calculations. So we'll have 1, 2, 0, and a 1. And this next one we're going to have, let's see, 0 and a 1 and a pair of deuces in the bottom. Alright, and let's multiply this through again. We go this way in the first matrix, down on the second. So 1 gets multiplied by 0, 2 gets multiplied by 2, and so we end up with 0 plus 4. Alright, now we move on to the next guy here. The 1 and the 2. Go ahead and see if I can erase that. I guess not. Okay. So we'll just go on this guy and this guy here. And so the 1 goes into the 1, that's 1, and then the 2 goes into the 2, making it 4. Okay, so now we are in the second row, so we'll be pulling from these elements here, and again 0, and then the 1. So first, for this guy here, we look at those two rows and columns. Row and column, should I say? 0 times 0, that's 0. 1 times 2, that's 2. And then for the last one, again, we're aiming for here, so we'll be pulling from this column there. And so 0 times 1, that's 0. 1 times 2, that's 2. Okay, and that is basically how we do it. Let's go ahead and clean this up. 4, 5, 2, and 2. That is our matrix. Let's look at this in Excel. We won't worry so much about having nice numbers since the computer is going to do the nasty arithmetic for us. So let's just set up two 2x2 matrices. 4 there, and we'll put an 8 there. So that's matrix number 1. Matrix number 2. Set up like that. Okay, here we are, and let's go ahead and multiply these through. Alright, so this element here, and we'll have to do this element by element, but it'll be good practice. So this equals this guy times this guy here. And just remember, always remember, we're going across on the first one, and we're going down on the second one. So this element, we're going to be working this guy here and these guys here. Okay, so plus, multiply here, times that guy there. And that's our first element. Alright, and now still looking here, but now we'll be pulling for these to find the element right in there. So this equals this guy times that guy plus this one. Okay. Plus this guy times that guy there. Okay, apparently Excel is going crazy. Right there. Alright, so you see it, hit enter, and there we go. Alright, so now we're working for the bottom two elements. So we will be pulling not from the top row, but from the bottom row here. And to get that next element that you see the cursor on, we'll pull from right there. So this equals this guy just like that. Right, notice it's just the same pattern over and over again, regardless of the how big the matrices you're working with. Oh, still pulling from there, sorry. And now we pull from right here. Right. Same pattern. And there you go. And that is our final matrix. Let's go ahead and gray it out. To indicate that that is in fact our matrix. And back to our handout. Again, note that in general AB does not equal BA. There are exceptions to that rule, but those are very specific indeed. In general, the order will matter, and you will not be able to multiply AB and expect the same result if you multiply by BA. Okay, I think this is long enough for this video. Next time we will be going over using what we've learned here to represent a two-equation, two-variable system with a matrix, and using matrix operators in order to find the result. So until then,